I'm Hyuk-jin and she's Signal. So today we're gonna talk about what's new in the PySpark 3.3 and what's next in the future PySpark version. Before I start, the Python language itself became the very popular, one of the most commonly used language, like front-end, back-end, like data scientists everywhere, we use it. And then for addressing large scale data, we use PySpark, and then PySpark became the very standard. So I'm very excited to talk about this today. All right, so before the talk, I would like to just share just who we are, and then just a bit of background, what's going on in general in the PySpark development in general. So I'm Hyuk-jin Kwon from Databricks. I lead the PySpark team in Databricks. I'm the second top contributor in the PySpark repo. Will be top one soon, hopefully. And then I work in many areas like the PySpark, Spark R, Spark SQL, etc. I also interested in infra. And she's Signal. She worked together with me in the same team. She is also one of the major contributor in the PySpark. All right, so a bit of background in the current development and what's going on. So we initiated Project Zen in Spark 2.0, and this actually came after the setup. Came after the Zen of Python that actually defines the setup, the principle to make the Python more Pythonic. For instance, it includes like you should have a one way to do the one thing. Yeah, so we borrowed this idea, and then we are trying to make PySpark more Pythonic, make it easier to use, and make it integrated and then make it working better with other libraries. All right, so as a part of Project Zen, we also introduced Pandas API on Spark in Spark 3.2. And this is another point that the community is trying to focus on, and we are heavily developing this. Pandas itself is very famous libraries, like all the data scientists use it, right? And there's a general problem. I mean, in fact, the Pandas documentation itself, they mentioned that the Pandas isn't a great tool for all the purposes. It cannot address the large scale data, and then it only works in the single node. So people have to use the PySpark, but PySpark, there's API difference between the Pandas and PySpark. But the Pandas API on Spark reduces the gap. So it makes the users much friendly with the scaling out their Pandas workload. So this is an example. This is a Pandas workload that reads CSV file to the Pandas data frame, but you want to scale out, and then you just replace the one input line, the first, and then it works in your existing Spark cluster right away. So this is what the Pandas API on Spark does. And then there are some blog posts I wrote, and then there's SPIP I proposed. That's, of course, passed, so we have it now. Yeah, so just check it out if you're interested in. All right, so this is so far the general background. The talk today, this is the agenda today. So I'm gonna share about what's new in Spark 3.3, and then what's next, and the future Spark version. More specifically, what's going on in the Spark development in general. Briefly, for what's new, Spark 3.3, we improved the performance of the default index in Pandas API on Spark. Briefly speaking, we see the 2 to 3 times faster performance improvement. And we added the Python time delta support. It works everywhere, create data frame as a parameter. And we also added the PyArrow interface for advanced users for better performance. And we improved the productivity by better autocompletion and the profiler for Python and Pandas UDF. I will talk about these details later. Yeah. And then for the future PySpark version, one of the biggest effort is that the Spark Connect project that Reynolds just yesterday, talked about it in the keynote, right? I'll talk about this a bit more here. And then we started to work even more closely with Py4j communities. I'll talk about this later. We are working on the non-Py support in PySpark everywhere. create data frame as a parameter. And we are working on the even faster performance and some feature parity like structure streaming. So Signal will present what's new in Spark 3.3 first, and I'll follow up with what's next in the PySpark future versions. So I'll leave it to you, Signal.
Thanks, Hyojin, for the great introduction. So let's begin with Pandas API on Spark. Like in Spark 3.3, we improved the default index. So what is default index? In Pandas, a default index is attached to a data frame or a series when there is no explicit index is specified by the user. So the range index is the default index tab of the default index. Here in the example, as we can see, it increases one by one. In Pandas API on Spark, we also attach a default index, which is also sequential when the index is unknown. For example, when we convert a Spark frame to a Pandas on Spark frame directly, because in Spark, we don't have the index concept. So as we know, implementing a global sequence is very challenging in a distributed environment. So we implement a global distributed sequence like on top of JVM in order to avoid the serialization and deserialization between the JVM and Python interpreter. Furthermore, we enabled optimization rules such as column pruning that is provided by Catalyst Optimizer. To be concrete, like previously on the left, the output RDD will truncate the Spark plan and blocks optimizations. But now, like on the right, dedicated Spark plan is preserved and enable the further optimization. In Spark 3.3, distributed sequence is the default index tab of default index. It is truly distributed and it scales out better. We did a benchmark on the default index tab between Spark 3.2 and Spark 3.3 on a 5-node cluster with instance type at 3x large. Spark 3.3 is more than 2 times faster. And that is not the end of the story. We are still trying to improve the performance of default index, which Hyojin will talk about the details later. And the second excitement is that we have a better API coverage. One highlight is the as-of join. So what is as-of join? It is similar to left join, except that it matches on the nearest key rather than equal keys. It is a very popular, very common operation, especially in time series analysis. And it is supported in Spark SQL natively, as we can tell from the Spark plan. So it can leverage all the optimizations provided by the Catalyst Optimizer. Besides that, we also implement more Pandas analog API. For example, the combine first call of data frame and time delta index, which we will talk about later. And in Spark 3.3, we have a complete summary of which Pandas API we supported. And that's about Pandas API on Spark. Let's move to the new functionalities in PySpark 3.3. First, time delta is fully supported in PySpark, including Pandas UDF and the Python UDF. So here in the example, we create a PySpark data frame with a column that consists of time delta data. And then we apply time delta arithmetic operations against the column. Internally, the time delta data is mapped to the datetime interval tab in Spark SQL. Time delta is also supported in Pandas API on Spark. That includes like create a data frame or a series consists of time delta data or the time delta index. So here in the example, we create a Pandas Spark series from a Pandas series that has time delta data and a time delta index. Second, we introduced the PyArrow batch interface. That is dataframe.mapInArrow API. With that API, we can view the data frame as arrow batches and apply a function, a native Python function that takes in and outputs an iterator of arrow batch. As the example shows, we have a data frame, and we define a function, takes in and outputs the batch. And after we call mapInArrow API, it results in a data frame as well. And the mapInArrow API extended the flexibility like on the data manipulation. Here, I like to illustrate that by awkward array library. So this is a library for nested and variable set data. As the example shows, for each batch, we will convert it to an awkward array, and afterwards, we convert the array back to a batch. So the nested data is vectorized and batch processed nestedly. Last but not least, we support Python standard string formatter in Spark session.sql API. Especially the curly braces indicate the replacement fields. And keyword arguments are identified by keyword names. So in the example, the TBL in the SQL string is mapped to the first keyword argument, TBL. Besides that, the get attribute operator dot and get item operator square brackets are also supported. Yeah, let's move on to the productivity enhancement. First, we enabled better auto-completion by inlining the tab hints. Previously, tab hints of a normal Python file are in a separate step files. As the example shows on the left, like previously in the dataframe.py file, we defined a take function. And in its step file, dataframe.py file, we have the function signature and the parameter tabs and return tabs. But now we get rid of the step files and inline the tab hints as part of source code, as you can see on the right. That is very important because editors such as Databricks notebooks and Jupyter notebooks or IDEs, they can leverage these tab hints for the auto-completion. So now, as you can see, we can see the parameter tab and the return tab are displayed in the editors. Second, we introduced a profiler for Python UDFs and Pandas UDFs. Previously, only a profiler for RDD operations is provided. With that profiling information for UDFs, performance optimization is made easier. We can know exactly what's going on in the UDFs. As the example shows, we can tell the number of calls, the cumulative time, and total time spent for each function call in the UDFs. So lastly, we provide more Pythonic error handling by standardizing the error messages, following the SPIP standardized exception messages in Spark. Especially, we create a JSON file to centralize the symbolic error classes and parameterized error messages. With that, we can easily maintain and audit the quality of error messages. Well, the Arrow framework is still evolving with the efforts of the whole community. We integrate that with PySpark. Let's look at an example. So here we catch the exception and take actions according to the error classes. And standardized errors also enables us to integrate with other downstream services. For example, some alerting systems such as Sentry. Yeah, that brings me to the end, and I will leave it to Hyukjin. He will talk about the future of PySpark.
All right, so the next is the what's going on in the future PySpark. We're developing very hard, and then there are lots of cool things, so I'd like to just quickly share here. All right, one of the biggest effort, the Spark Connect project. This is basically, in my perspective, it's just remote API layer, so it can work together better with other applications or IDE or notebooks. And what it does is that it will connect to the Spark driver side, and then through the RPC protocol, it will send unresolved logical plans to the Spark driver side, and then Spark driver side analyze it, optimize it, and execute it, and then collect the data to the remote API side in Arrow format. So this is basically what the general picture of this remote API Spark Connect project. What it means to end users, right? This is important. It opens lots of possibilities. For instance, the first thing is that it dispatches the computation in driver side to the cluster. For instance, we currently don't support the interactive shell with the, for instance, Yarn cluster mode or Kubernetes cluster mode. We don't support that because the driver side, the computation cannot be dispatched to the cluster. The driver has to be in your laptop, right, to run the interactive shell. But with this, we can use Spark as a service. So in your laptop, you just open your remote API, and then the Spark is running in your cluster, somewhere. So you can just connect, and then you can just run the interactive shell. Yeah. So this is one of the biggest benefit in this project. And another one is that the other language supports will be very easy, right? For instance, the Spark R currently, it implements a very complicated logic to communicate with JVM. It has its own protocol. And I know there are some third-party libraries, for instance, .NET or C++ support for the PySpark. And they implement their own logic to communicate with JVM, very complicated. But once we have this standard RPC protocol, and that we can very easily implement other languages. The language, like we will just have one library that has the logic of the connection. It doesn't even need other dependencies. It just implements the RPC protocol, and then that will work with the Spark driver right away. Third one is the security stuff. Currently in Spark driver, when you run that, then the users can run like arbitrary codes, right? Like they are able to access, anything in the computer. But with this remote API, the users are forced to only use the PySpark, the data frame API only. Separation is very important. There's no way to do, other stuff. This is very important too. Lastly, the upgradability. So you can upgrade very easily. For instance, the remote side, it only implements the connection logic, right? The RPC protocol. So you don't have to think about the dependency conflicts. You just upgrade it, and it will work right away. This SPI API, SPIP, just got passed in a couple of weeks ago. So if you're interested in, just check this link out. All right, the next is the Py4j improvement. Now we have a brand new organization for Py4j, and then we have brand new maintainers of Py4j from Databricks. So both community of Py4j and then PySpark, we will work together even more closely, and then for greater synergy, like for the benefit of both projects. By the way, the Py4j, in case you guys don't know, the PySpark, we use the Py4j heavily to communicate with the JVM side. Yeah. This is important because it's a short-term plan. Well, actually, we already implemented the Python 3.10 support in the Py4j. So PySpark also support the Python 3.10 out of the box. And we also resolved several blockers or like resource leak problems in the PySpark. In Py4j, we made a fix. As a long-term plan, we are working on the JDK 11 or 17 support that, of course, the Apache Spark are currently supporting. But there are some like slight bug in the Py4j, so we gotta fix it. And we are also fixing some related issue for the native NumPy support in PySpark that I'm going to talk about it like, next slide. All right, so as I just said now, we are working on the native NumPy support in PySpark. I'm saying that the native NumPy support everywhere. Create data frame as a parameter, or let's say PySpark SQL functions, PySpark MLlib. For instance, the 1 or 2 dimensional NumPy array will be able to be created as a data frame, just like what Pandas does. And as I just said, will be able to be passed as a parameters or everywhere. Next one is about the documentation style. We actually improved a lot of the PySpark documentation. We switched the documentation style to the NumPy doc style in Spark 3.2, I guess, right? So the documentation became much better, much pretty. The NumPy doc style is pretty, right? But the problem is that there's some documentation don't have the parameter and the examples. For instance, even some example, you just copy and paste, and then it complains that, for instance, look at the right side, df is missing. What's df? You're a newbie, you don't know how to create what's df, right? You should be able to copy and paste. It should work right away in your shell, right? In case of the Pandas API on Spark, we have the self-contained example. So most of them, you can just copy and paste. It works right away. It has a good parameter documentation. So we plan to document everything in other packages too, like Spark SQL, Spark ML. So you can just copy and paste example. You're a newbie, you just copy and paste and try and learn, right? But it's not able in PySpark. So we are going to make it able. Another one is performance. We improved a bit of performance like this release, right? But we are working on even better performance. For instance, we're thinking about this source native index that is about default index. So the default index sometimes requires a shuffle. For instance, in Pandas, by default, it creates a range index, right? But it's challenging in this distributed index because each partition should know each other, so it requires shuffle. So it is challenging, and then it requires computation. So ideally, we should get rid of it. But we are currently requiring this. So we are thinking about leveraging other modern source. For instance, JDBC or Parquet or ORC, they actually have some index implementation under the hood. And then for instance, Parquet or JDBC, they expose some interface to leverage this index. So we are trying to leverage this. So get rid of this computation and then use this index right away. Yeah. We're working on this, then hopefully we can make it in Spark 3.4. Right, another one is that the optimized create data frame with Arrow. We in Spark SQL, we have set up a very nice optimization rule for smaller data set. So you create a data frame, let's say in Scala side, and it actually doesn't send the data to the executor. It just creates the data frame. It holds the data within the driver. So when data set is very small, it doesn't cost a network, and then you don't have to send the data. So it is actually becomes much faster than actually just distributing smaller data set. And then it is useful especially in the case that, like, we have some cost-based optimization rule, right? And then since the data lives in the driver side, we know the full size, like, we know the length of the row, we know the byte of size. So we can leverage this to the cost-based optimization or broadcast hash join. But in create data frame in PySpark with Arrow, we don't leverage this so far. So we are going to leverage this. And then in the benchmark I performed internally, it shows that at least 70% performance improvement. Right. The next is that we are working on some feature parity. So we are making some more features that's matched with other components like structured streaming. This is one of them that's actually internally the customer like this very much. This streaming query listener that this already exists in Scala side, what it does is that you can add some post hoc logics for the streaming queries. So like for instance, each batch process, you want to trigger something, or like when the query exits, we want to do something, you can add some custom logics. This is useful, especially with the observable API. We have the observable API. So what it does is that you can add some like custom metrics. So how it works together with this, you can add some custom metrics, and then the streaming query listener can watch and get these metrics, and then you can add some like logics to play with these metrics. This is one example. I'm counting the total count of the CSV files, CSV rows in the CSV file. Now I'm also counting the number of the malform row. So if the malform row is like, I don't know, goes over like, I don't know, 50% or something, you can add some like alerting logic. You can just add some like RESTful API to the third-party alerting system like Sentry. And then that will like magically report to the other, other chains. There's a like fully working example in the blog post I wrote here. So if you are interested in, check this out. All right, lastly, the latest Pandas API stuff. So now we are officially matching the API to the one specific version in Pandas. So for instance, the Spark 3.3, now we match with this Pandas 1.3.0. So you can expect the same API coverage, same fix, same behavior. Yeah. In the current dev, we're following the latest Pandas for now. This is actually still in discussion. And then there are lots of community support discussion. There's one discussion here in the link. So if you're interested in, I hope you guys check this out. All right. Forget about everything we said today. There's 2 slides, all key takeaways. All right. I'm going to say now. So remember these 2 slides. First, for Spark 3.3, we improved the performance in default index with the API coverage. The performance became 2 to 3 times faster. There's full API coverage. There's full API list supported, the Pandas API list. This is available. This slide will be available, I guess, later. So you guys should be able to click it, hopefully. Yeah. And then we added the Python, the time delta support. There's Arrow batch interface for advanced users for better performance. And then we added the profilers for the Python and Pandas UDFs. That's it for 3.3. For the future Spark versions, we are working on the Spark Connect project. That's basically remote API layer. That's useful because you can dispatch the driver side computation to the cluster side with interactive shell. And we are working on the NumPy support that works everywhere, create data frame or parameter. We're working on even faster the performance with default index. We want to leverage the source native index, like index JWC, blah, blah. And we are also working on the feature parity, like observable API, streaming query listener, and the Pandas API feature parity. All right, so that's all we prepared. If you have a question, I'm happy to answer.
If there's any questions, please raise your hand. I have a mic here and happy to come by and allow you to ask a question.
Databricks also has this another library called koalas, right?
Yeah.
How is this different than that?
Sorry, I didn't.
How is this different than the koalas library?
They're the same.
Oh, okay. Okay, is it just renamed or?
Yeah, we port the koalas into the Pandas API on Spark. And then, okay, there's actually some difference. So when it was in koalas, we couldn't, for instance, we didn't make the change in the JVM side. It was pure PySpark code before, but we ported it to the PySpark, right? So now we can add some the dedicated, we can make some JVM change together. That's why actually one of the reasons it became super fast now, because we made some change in JVM side. That's a good question, yeah. Is there any question?
If you have a question, please go ahead and raise your hand, and I'll come by with the microphone.
All right.
What's the difference between two Panda, the classic one, and Panda API function?
Difference between SQL
Two Panda and Panda API function.
Sorry.
The difference between two Panda and Panda API, the function.
Sorry, can you repeat this for me? Sorry, I cannot hear. What?
Yeah.
Two Pandas and Pandas API. Yeah. I see. There's two Pandas. It collects the data frame into the Pandas data frame. So all the data will be collected into the local. So if the data is so big, then you will easily just meet the out-of-memory error. And then the Pandas API on Spark, we we implement this Pandas API by using PySpark data frame API, basically. So it will fully leverage the Spark SQL, the optimizers. For instance, you perform the same operations multiple times. That will actually will remove all unnecessarily the computation. It will be optimized. Yeah. In short, two Pandas will collect the data to the Pandas data frame into your driver side. Pandas API on Spark, under the hood is Spark SQL. Yeah.
All right, we have another question here.
Hi, regarding Pandas UDFs, is there any thought or plan on adding the ability to co-group more than two data frames? Again, that's a use case that we are interested in. I know that you can group a data frame on a column or on some criteria, and then you can co-group another one and apply UDF on that, and you get two data frames. Is there the ability to do it for more than two data frames?
Sorry, my brain is foggy today, so I don't know. So can you sorry?
Okay. Okay. In Pandas UDFs, the new API that was released, I think in 3.1, if I remember correctly, there's the ability to group by a data frame, right, a Spark data frame, and then co-group another data frame on the same key or same condition, and then apply a UDF where you get two Pandas data frame in the input, right? Co-group. Is there any plan on adding the ability to co-group more than two data frames, like 3 or 4?
Oh, yeah, we do. We do have plan. Yeah, yes, but okay. Firstly, we do have some plan to add other types of the Python UDF. Yes, but I think actually we are discussing. I think the first thing have to do is that we should check the feedback first. I mean, we cannot just develop the things that the developer like and then just, ending up there's no users use. So I'm trying to actually collect some feedback. What kind of other Python UDF would user need, right? Yeah, so we'll see. I mean, I'm still trying to collect the feedback here and there. Yeah, so.
All right, if there's any other questions, please join Hyukjin and Shinrong outside as we are out of time at this moment. Thank you everyone for joining. And
thank you so much.
Thank you.